the screen is visible now? Okay. Okay. So we started seeing the buffer solution. So my humble request is please listen carefully. So then only you understand something. Okay. So the buffer solution is buffer is a solution that resists the change of pH by the addition of acid or base more effectively than equal volume of water. This I already explained, I think. The buffer solution consists of two things, weak acid and its conjugate base. That is salt. If you take acetate buffer contains acetic acid, that is a weak acid, and the sodium acetate, that is the salt present in this buffer. Like that citrate buffer, it contains citric acid and sodium citrate. So all of you take paper and write buffering action of the buffer. So here we have taken acetate buffer, how that acetate buffer resists the change of pH by the addition of alkali or the acid. So already we know this. So acetate buffer that contains weak acid, acetic acid and sodium acetate. So don't consider this. Okay. So first all of you write in the paper that the composition of the acetate buffer, acetic acid and sodium acetate. Just imagine you have taken a beaker, in that you have added a buffer, that is acetate buffer. Then with that you are going to add sodium hydroxide. If sodium hydroxide dissociate into sodium and hydroxide, so the hydroxide ion concentration is increasing, means pH also will increase. Okay, it takes the H plus ion and that increases the pH by decreasing the H plus ion concentration. Can you able to follow? So, Inama? Yes. Okay, so we have added sodium hydroxide with the acetate buffer. If in the product side, if you get OH minus ion, okay, free OH minus ion, then that increases the pH. That increases the pH by, okay, we already know if you add alkali, definitely that increases the pH. So see, after that you write the reaction. Sodium hydroxide reacts with this and form 2 molecules of sodium acetate and 1 molecule of water. Here in the product side, there is no OH minus ion. So what will happen? There is no change in the pH. Like that you write reaction for the addition of the acid. So here the same way, in a beaker we have taken acetate buffer, then with that we are adding HCl. For that you have to write the reaction. Acetate buffer plus HCl. In this side we expect free H plus ion, because HCl dissociate into, how that will dissociate? H plus and Cl minus. If free H plus ion is present, that indicates that will decreases the pH. But in both sides, there is no increase in OH minus ion, or there is no increase in the H plus ion. That OH minus ion formed and also the H plus ion formed from the alkali and acid are neutralized by the buffer. So in either case, in the addition of alkali or in the addition of acid, there is no change in the H plus ion. What indicates? This indicates that there is no change in the pH, that resists the change in the pH. I think you can able to follow. Do you have any doubt? ரொம்ப சிம்பிள் தான். நீங்க வந்து ரியாக்ஷனா எழுதுங்க. அசிட்டேட் பஃபர்னா what are the constituent in the acetate buffer? Acetic acid and sodium acetate. With that you are adding sodium hydroxide. So acetic acid plus sodium hydroxide, sodium acetate plus sodium hydroxide. Then if you write a reaction, we'll get 2 molecules of sodium acetate plus water. So there is no OH minus ion or there is no H plus ion. So After that, for the addition of the acid also, you have to write the reaction in the same way. Acetic acid, sodium acetate plus HCl. In this case, we'll get 2 molecules of acetic acid and 1 molecule of sodium chloride. There is no H plus ion or OH minus ion. So there is no increase or decrease in the pH. This way only buffer resists the change of the pH. Okay, so two important concepts here. A very important thing. One is pH. Already we know the pH is the negative log of hydrogen ion concentration. The pH depends upon the hydrogen ion concentration. Hydrogen ion concentration is increasing means pH will decrease. Hydrogen ion concentration is decreasing means pH will increase. So always the pH of the solution depends upon the concentration of the H plus ions present in that solution. Then another thing is the pKa value. What is this pKa value? Already we know the Ka. What is Ka? A plus B, that gives C means the rate of reaction. So the rate of reaction, already you know how much of product formed per unit time. That is only known as rate of reaction. Always we'll write rate of reaction for all the reaction. That is apparent. Apparent means that is changed by the concentration of the substrate, means that is known as apparent. Okay, leave it. Always we'll write the rate of reaction and denotes the rate of reaction as Ka. Okay, for all reaction, we'll write Ka. So if you write this Ka for weak acid means that will become an ionization constant. Okay, ionization constant means we'll consider this is a weak acid that forms a reversible reaction. It forms A minus plus H plus. So here also we'll write a rate of reaction. Now this is not a rate of reaction. This is known as ionization constant or dissociation constant. Why we are saying this is an ionization constant means this reaction is ionization reaction. Why we are saying this is a dissociation constant means this reaction is a dissociation reaction. So minus log of Ka is equal to pKa. So now here we know what is Ka, what is pKa. So pKa is equal to minus log of Ka. Already இதெல்லாம் உங்களுக்கு தெரிஞ்சிருக்கும். So these two are the very important two concepts related to the buffer. Okay, this already we have completed. These are the problems I'll post, or otherwise we will copy and write. So next thing, very important thing is the Henderson and Hasselberg equation. This also you have studied in your class, in your 12th standard or 11th standard in detail. But anyway, we have to see here also what is Henderson and Hasselberg equation means. It is a quantitative relationship between pH, pKa and buffering action of the buffer. What is meant by buffering action of the buffer? Already we know the mechanism of the buffering action. That means how efficiently that resists the pH change. That is only known as the buffering action of the buffer. So this buffering action of the buffer, that is related to the weak acid present in that. So pKa is equal to ionization constant of the weak acid. So if weak acid dissociate, that changes the pH, or otherwise this resists the change of the pH. So there is a relationship between pH, pKa and buffering action of the buffer. So we are going to see quantitative relationship between these three. So what is Henderson and Hasselberg equation means? It is a quantitative. That means here one time it is changed, means pKa 2 times changed. This is 3 times changed. Like that we can quantify the relationship. So it is a quantitative relationship among pH, buffering action of the buffer, pKa. So this is expressed in a single equation. That equation is only known as Henderson and Hasselberg equation. So what is Henderson and Hasselberg equation? This is the quantitative relationship between pH, buffering action of the buffer, and pKa of weak acid. Okay, so now all of you take paper pen எல்லாம் biochemistry class வரக்கூடாது. Anyway, you take. ஏன்னா, we are going to derive the Henderson and Hasselberg equation now. Okay, all of you write the derivation of Henderson and Hasselberg equation. We have to start the derivation from the ionization reaction of the weak acid. Here you have to consider this as the weak acid. It may be an acetic acid, it may be a citric acid or any acid. Okay, this is HA is a weak acid. This will ionize or dissociate into H plus and A minus. This reaction is known as ionization reaction or the dissociation reaction. So next thing, you have to write Ka for this. Ka is equal to rate of reaction. Already you know, Ka is equal to concentration of the product divided by concentration of the substrate. This is already we know this. Okay, if any reaction, you have to write the Ka means the formula for determining the Ka is equal to concentration of the product divided by concentration of the substrate. So like this, can you write Ka for this? You write and tell what is the answer you got. Write Ka for this equation. Ka is equal to concentration of the product divided by concentration of the substrate. If you have completed, say something. Finished? What class இருக்கீங்களா? Can you able to hear the voice? Yeah. ஏன்னா Ka எழுதிட்டீங்களா இல்லையாப்பா? என்ன what is this Ka is equal to? Have you written Ka for this? சொல்லுங்க. சொல்லுமா? பிளஸ் வருமாப்பா மல்டிப்ளிகேஷன் தானே ப்ராடக்ட் கான்சென்ட்ரேஷன் ரெண்டு ப்ராடக்ட் இருந்தா மல்டிப்ளிகேஷன் தானே வரும் K is equal to again you repeat what's your name உங்க பேர் என்ன you change this equation and tell K is equal to Super, super. So if you got this one, it's okay. K is equal to concentration of H plus into concentration of A minus divided by Ka. Okay. So next, solve the equation for H plus ion. Because we want H plus ion concentration, only the H plus ion concentration determines the pH. So we have to solve this equation for H plus. You have to H plus in this side, that's all. Can you? What is it? It's simple simple thing. Why you are taking this much time? H plus ion concentration is equal to? கண்ணா எப்படி அப்படி வரும்? concentration of திருப்பி சொல்லுங்க. I didn't follow you. H plus ion concentration is equal to Ka into அப்படியே தானே இருக்கும் A minus. ட்ரை H plus ion. கிளாஸ்ல இவ்வளவு பேர் இருக்கீங்க, ஒரு ஆள் கூட இந்த சால்வ் பண்ண முடியலையா? நீங்க சால்வ் பண்ணீங்கன்னா we can proceed. Otherwise I'll stop the class and go. What is this? It's a very simple thing. HA மேல டினாமினேட்டர்ல இருக்குன்னு சொல்றீங்களா? எப்படி எப்படி வரும்? கரெக்டா சால்வ் பண்ணுங்க. H பிளஸ் இங்க கொண்டு வந்தீங்கன்னா அது கீழே வரணும். ஆனா நம்ம மேலதான் எழுத போறோம் H பிளஸ். அப்போ எது அப்படியே தானே இருக்கும். அது எப்படி H பிளஸ் மேல போகும்? K இந்த பக்கம் கொண்டு வந்துட்டு நீங்க H பிளஸ் இந்த பக்கம் கொண்டு வர போறீங்க, அவ்வளவுதான். அப்போ எப்படி A மைனஸும் KAவும் HAவும் எப்படி சேஞ்ச் ஆகும்? ஆகாதுல்ல. Okay, think it. H plus is equal to Ka into A minus divided by HA. So this is the equation. Okay. Next thing, take logarithm in both sides. Solve பண்ணிட்டு கூப்பிடுங்க. Take logarithm in both sides. Log H plus equal to log pKa. Plus minus into divided by என்ன வரும் நீங்க தான் டிசைட் பண்ணும். Log A minus divided by HA. ஏமா ஒரு ஈக்குவேஷனுக்கு லாகரிதம் எழுதுறதுக்கு இவ்வளவு நேரமா? What's this? Have we finished? You got this equation? Roll number 82, you are in class? 83.